during the map test, and they were talking about the trig. And they said, oh gosh, my math 2 teacher let me use a toolkit all year, so I never memorized the trig. Just to let you know, trig is on the next quiz in chapter 2 with no calculator and no notes. So if you don't know the trig, you're gonna have to figure it out. And you've got a couple week warning here. So we're gonna start working on that right now. The way that I remember, that's not true. I haven't memorized because I'm a nerd, but if I were you, the way I would remember it is called SOHCAHTOA. Okay, so SOHCAHTOA is how I use, oh, look, it's Mr. Toolkit himself.
Yes, very good. SOHCAHTOA.
How are you? What is this? It's cards. Oh, it's they printed them on. Oh,
Fancy.
did T have to do those? Probably. Oh, I got nothing. All right. Okay, so SOHCAHTOA. This stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, and if you can remember this, then you can do all of it. This actually is the equations, and it'll help you. Okay, so first one, 17, we're going to mark this angle 30, and we're going to say, okay, these two sides here, are they opposite, adjacent, or hypotenuse? I always look for the hypotenuse first, which is 8 in this case. So on the 8, I'm going to put an H. And then you say to yourself, is X across from the 30 or is it next to the 30? And it's across from the 30, so that's opposite. Okay, opposite and hypotenuse is sine. So it's the SOH part of SOHCAHTOA. Okay, and this is how you set it up. Sine 30 degrees equals opposite over hypotenuse. So sine, so SOH means sine opposite over hypotenuse. Okay, now on the quiz, it's very specific. And you're like, Mrs. Talbot, this is impossible to do without a calculator. It's true, except for you're going to leave your answer in exact form. So I'm going to show you both exact and approximate form. In this case, you would multiply both sides by 8 to get rid of the denominator. And you would have 8 times sine 30 degrees equals X. On the quiz, this would be your final answer. This is called exact form. And you just leave it like that. I know it feels weird to leave it like that, but you have to just walk away from it. It's done. Okay, now we're going to do the approximate form. I think this one actually comes out evenly though. I think it's 4, but anyway. Okay, now who has a new calculator? Brand new, straight from the factory. I just opened the package. Okay, if you have a new one of these, at the top here, it's going to say radians, and you don't want to be in radians. As a matter of fact, you don't want to be in radians in any of your calculators. So what you need to do is hit the mode button. And actually, we're going to use a graphing calculator today. So why don't you guys go grab one if you don't have one right now? Okay. And I can tell that my calculator is in radians because it says radian right here. I don't want that. Notice the problem has degree symbols in it, so I need it to be in degrees. Okay, so hit the mode button. It's right next to the blue one. So find the blue one. Right next to it is the mode button. It'll show you all of the settings for that particular calculator. And what you want to do is scroll so that it's blinking over top of degree and then hit enter. So blinking over top of degree and then hit enter. So you want to change the mode to degrees, and then to get out of this back to the regular screen, go second quit. Quit is right above the mode. So second quit. Second quit will always get you back to the regular screen no matter what you're doing. 8 times sine 30 is 4. In this case, 4 is an exact number. It's not approximate, but when you have directions that say round to the nearest tenth, most of them are going to come out to be decimals. The reason I boxed this is because this is what I want on your quiz. So yes, sir. Probably. Most of the time you'll do approximate value. As a matter of fact, the only time that you won't do it is the quiz because you won't have a calculator. Every other time you'd finish the problem by using the calculator. Okay, now number 19. First thing I want to mention about number 19 is this little symbol right here is called theta. His name is Theta, Theta, theta. That is a lowercase theta. It is the variable that we use for angles most of the time. Sometimes it's x. It can be anything, but theta is pretty much what we use in general. You're going to see thetas all over the place when you do these. You've seen theta before, right? Okay, just checking. All right, so we're looking at theta here. I'm going to mark the angle just for my visuals. And I don't have any label on the hypotenuse, so I'm not going to put an H there. The 3 is across from the theta, so that's opposite. And my 10 is right next to the theta, so that's adjacent. And then I just scroll back up here real quick. Opposite and adjacent is TOA. So you're going to say TOA tan of theta. This time you don't know what the angle is, so the variable goes there, equals opposite over adjacent. Okay. Do you remember what is the undo of tangent? Yes. Inverse tan. And don't say tan to the -1, please. That is like terrible. It's like saying sin. Don't say that. Say sine. Don't say tan to the -1. That's not really what that is. It's inverse tan. You can say inverse tan or arctan. Those are the proper ways to say that. Okay, so this is how we write it though. Theta equals tan inverse of 3/10. And that's as far as you can go without a calculator. Okay, now we're going to practice it on here. Tan inverse, you need to hit second tan. Tan inverse of 3 divided by 10 is 16.7 degrees. Approximate. You're thankfully done with the domain and range page, so we can put the warm-ups away. Now, I'm going to give you a warning. Today, on Friday, we have a minimum day. I probably won't stamp the warm-ups, but on Monday, we don't have school. On Tuesday, I'm definitely going to stamp your warm-up. So if you missed days or fell asleep or were tardy, whatever, make sure you have those done by Tuesday because those are an assignment for the class. Okay, your packets can go away. We're all done with your packet for the day. Okay. Today we're going to do a statistics lesson. This is basically the fundamentals of what you need to be able to take A through stats. And we're going to do histogram, Hobbs plot, find the mean, the median, standard deviation, range, and IQR. And interestingly enough, we're going to use your RIT scores from your math test for your class in order to make these are actual scores. So if you guys can pass out a paper that I put on your tables with the list of numbers on them. Group A is actually your class. So that is everybody's math test score in the whole class. Nobody is singled out. There's no indication of who's who. Okay, now we are going to do two of these. I'm going to do your class with you as notes, and then you guys are going to repeat that process for group B in your notebook. And at that point is when I'm going to come around and stamp whatever you have to stamp. Does that make sense? Okay, if you need a graphing calculator today, I'm going to teach you how to do quite a bit of this on the graphing calculator. Okay, now for your math scores, I said I was going to go over what the paper meant. So you don't have to get your paper out if you don't want to show people your score. But just for the next few minutes, what is a RIT score? Math Growth uses a scale called RIT to measure student achievement and growth. RIT stands for Roche Unit and is a measurement scale developed to simplify the interpretation of test scores. It is an equal interval scale like feet and inches on a ruler, so scores can be added together to calculate accurate or class or school averages. The RIT scale ranges from 100 to 350. So just so you know, a kid in kindergarten might get like 100 and something. I think Miss Rice told me what her first grade was on. I can't remember what she said. But it goes from 100 to 350. So your calculus students would hopefully get 350 somewhere around there. We're kind of in the middle, right? So we should be somewhere in the middle. RIT scores make it possible to follow a student's educational growth from year to year. Imagine what Ms. Rice's kids' graph is going to look like on the back of his page. You guys know your graph on the back of your page. It has all of your, this is going to be like landscape style. It's going to be populated. So, oh, it says student may score in the 170s in third grade and advance throughout high school. Okay, so I've given you an average score here. Almost everyone in this class scored above 12th grade. They're saying 12th grade in the fall would be 233. If you got above 233, then you're good. So, you know, any of these, yeah. Well, just so you know, so you can feel happy. There's the grade level equivalents about for RIT scores. Okay, here is your homework. It is 4 problems, 103, 104, 107, and 109. And here's my joke. It said, do not remove bar from repeating decimal, and then there's a hole in the wall. Do you get it? Because what would happen if you took the bar up? The threes would shoot out forever, right? Apparently they already did. Guys are so mean to me. I'm gonna stop showing these. so mean.
No, it was just a, why you say that?
Okay. We're gonna do notes first. It's not gonna be long, I promise. It's a very short set of notes actually, and then we're just gonna jump right into histograms, box plots, graphing calculator stuff. As I said, I'm gonna do group A with you, and then you guys are gonna do group B in your groups, ironically. Okay, first thing you need to know is that SOX is an acronym here. It stands for Shape Outlier Center Spread. It's how even the AP Stat students remember to answer all the questions about describing a distribution. And for shape, I put little shape guys on your table. So if you could find that page, and then we're gonna arts and crafts that into our notebooks. And I lost mine. I had it right here. It was right here. It was right. It was right. It was right. It was right. Oh, here it is. Okay. So each one of you needs one of these little dudes. And you're either going to tape or you're going to cut it out, tape and glue stick or whatever you feel like into your notebook. Someone's going to have to step up on the cutting in your group. There's way too many of them per group. You only need one of these. If you have extras in your group, you can just recycle the rest of the paper. I made way too many copies. I don't know what happened. I got excited about stats. Made so many shape guides.
Oh,
Yeah, you don't need all of them. I don't know what happened with me. I was trying to save paper. Again, it's not you, it's me. Okay, while you're finishing this up, let's talk about these. So there's more than 6 shapes of histogram. There's an infinite number of shapes of histogram. That's probably not true. Probably not infinite. There's a very large amount of different shapes. These are just the most common examples. Sometimes bimodal ones can be bimodal and right skewed. Sometimes multimodal ones can be roughly symmetric and multimodal. Sometimes they have different things in common. I'm not going to kill you over that in Math 3. That's more of an AP stats thing. I'm going to try my best to make it easy to figure out the shape. However, I don't actually know what the shape of either of these histograms is going to be when we make it in a moment with your student data. I didn't go ahead and do that myself ahead of time. It's fun, mystery stats. That's the way it always is. Okay, the other thing I want to say, first of all, unimodal, that means one mode. The mode is the most, so one peak is what it's saying. Bimodal means two peaks. Multimodal means multiple peaks. Does that make sense? So remember, from middle school, mode is the most, so that's the peaks. So that's what that word means. Those words mean. Now, the other thing I want to talk about is skew left and skew right are the opposite of what your brains want them to be. When I say something skewed left, to me, that means that all of my data should be on the left side. That's not what it's saying. Okay, I want you to imagine that you took a picture with your phone, okay, and then you took the corner of it and pulled it this way. You skewed it left. What some students do in my AP Stats class is they take the word skew and they replace it with the word tail. So instead of skew left, they think left tail, tail to the left. This being the tail, like it's a Tyrannosaurus Rex, but his tail is going to the left, and then this one, his tail is going to the right. So that's how they remember left skew versus right skew. They say right tail versus left tail. Whichever helps you. I'm just trying to give you all the ideas. Okay, now outliers. That's the O. There's actually a formal process to determine whether a number is an outlier, and I'm not going to teach it to you. So for us, we're just going to say any value far from the rest of the data. Now, in my class, because I'm the AP Stats teacher, when I talk about outliers in Math 3, I always say possible outlier. I don't state that it's an outlier because there's an actual process you need to go through to figure out that, and we're not learning that this year. So when I say outliers, I'm going to say possible outlier. Okay, center. C is center. And there's two measures of center that we will use in this class, mean and median. I'm going to show you how to calculate both the mean and the median on your graphing calculator, but they do have symbols. The mean is this one. That symbol is called X bar. And I don't know if you noticed, but there's a poster over there that says, I hear she is really mean, and the teacher is the X bar symbol over there, which hilarious. If you can't see it, just go that way out the door. Okay, and then the median is just a capital M, not that exciting. And then spread is the last thing. Spread means how far out apart the numbers are, basically. There's three measures of spread that we will work on in this class. Range, which is max minus min. Range doesn't get a fancy symbol because it's pretty much useless, but sometimes it's all you can do. IQR, which is quartile 3 minus quartile 1. Does that sound familiar to you guys? Interquartile range. Okay, it doesn't have a fancy symbol either. It's just IQR. And then standard deviation. Okay, now I'm not going to make you do it by hand in this class. I also call it Saint Dive, like it's some kind of church saint. And that's just because I'm too lazy to write the word standard deviation. So I changed it to St. Dev, but it actually has a symbol also, which is S with a subscript of X. So I'm going to say S sub X, like S subscript X. That's the notes for that. That's all you need. Okay, now we're going to do number 101, which is going to be group A. So, hold on, let me make sure everybody's got this. Now, I'm going to tell you something. Number 101 is going to feel long. That's because I have a lot to teach you while we're doing it. When you guys do number 102 for your group B data, it'll go much faster. I thought. Okay, so find me a different spot. I picked a new page. You don't have to. I have a lot to put on this page. You guys can do your notebook however you want. Make your graph big though. I actually have no idea what this graph is going to look like. I did not do my homework. I just prefer to have the fun surprise. Okay, now the directions on the paper tell us how to scale. It says create 2 combination histogram box plots. So we're going to do this group A first, and then you guys are going to do the other one for group B. It says start at 200 and use a bin width of 10. Okay, what does that mean? That means that I'm going to start here as 200, and then the bars of my histogram are going to be 10 apart. So I'm looking at our data, and the highest was in the 80s, I believe. So we're going to go 210, 220, 230, 240, 250, 260, 270, 280, 290. Okay, does it make sense when I said start at 200 with a bin width of 10? Do the bins have to be 2 graph paper squares apart? No, I just wanted to do that so it looks pretty, because, I want it to look pretty. Okay, and then my x-axis is going to be labeled with whatever the data is. Okay, the y-axis gets labeled with 1, 2, 3, 4. We're going to go up to 10. Again, this is a mystery. I have no idea what this is going to turn out to look like. So just go up to 10. And on a histogram, the y-axis is always labeled with the word frequency. Frequency means how many times did it occur. Okay. The next sentence I say is going to be the most important sentence I'm going to say about histograms. If you have a number that falls exactly on one of the bins, it goes in the higher bin. Let me say that again. If I have a number that falls exactly on one of the bins, it goes in the higher bin. let me explain. This is why I chose the joke I chose for today. You guys didn't think that there was an actual reason for the joke, but there is. This bin will be all the numbers from 200 to 209.9 repeating. 210 will go in the 210 to 220 bin, I'm saying. So if it falls exactly on the line, it goes in the upper one. That's the most important thing you need to know. Okay. And now we just count. All right. This is the worst part. Are there any between 200 and 210? So are there any between 200 and 209.9 repeating? No. 210 to 219.9 repeating? No. 220 to 229.9 repeating? Yes. Okay. So that bin is going to have a bar that is 1 tall because there's one number between 220 and 229.9 repeating. Okay, now I'm going to say it in an easier way. Are there any numbers in the 230s? 1, 2, 2. Any numbers in the 240s? 1, 2, 3, 3. Can anyone check me? Because I'm writing in the flare pen. 3. I hope so. Okay, 250s. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cripes, I should count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Kind of a jump. 60s. 1, 2, 3, 4, 5. 1. Is there really only 4? Nope. Hold on. This is the worst part of the whole thing. Okay. 260s. 1, 2, 3, 4, 5. Okay. Just trust yourself, Mrs. Talbot. 1, 2, 3, 4, 5. And what? Okay. This is a really weird shape. So I'm gonna get my little shape guys here and be like, well, this one I'm gonna call roughly symmetric. Symmetric meaning if I folded it in the middle, it would sort of match up on both sides. So like if I folded it here, my paper, you know, this is tough. It's tough. This is, it's stats. It's not math. There's a lot of times two possible answers for shape that I would take as correct. But when you guys do a quiz or test with this, I'll try to make it really obvious. But as I said, this is real. So I didn't know. Okay, do we see any outliers? I don't see any, and that's a good thing. Outliers are bad. You want to say none. None is a better answer than having outliers. And you're like, well, what if somebody got like a 350? That's not bad. Okay, what I mean is if you're working with a data set, you don't want there to be extreme values on either side. That's disproving of whatever you're trying to show in your graph, but whatever, doesn't matter. Okay, now we're going to make the box plot next because that's going to help us get our center and spread. Okay. I need to show you how to make the box plot on the graphing calculator because it's much faster than doing it by hand. Okay, so first thing you're going to do is write some calculator directions here. Okay. So first get your calculator directions down. My people in the back, I'll move this up. Okay, then get your calculator out when you're ready. Okay, I'm going to try to go slow. First thing you need to do is locate the stat button. It is 2 over from the green. Stat button, 2 over from the green. I'm right here. Stat. Enter. Type values into L1. Does anybody have stuff in their L1 already? Okay, we need to clear out our L1 if we do have stuff in it. So I have stuff in mine. What I'm going to do is take the arrow keys. I'm going to scroll up to the top where it says L1. So L1 is highlighted. And then I'm going to hit clear, enter. So scroll up to the top, clear, enter if there's anything in there. Okay, so now I'm going to get out my numbers and we have to be really careful. 253, enter. 276, enter. Okay, now I'm going to shut up. Go slow, careful. If you're done, you can try to follow the rest of the directions or you can wait for me. Is anyone still typing numbers? Okay, guys, let's follow the rest of the directions. Now, we did this, we did stat, enter, type values into L1. Now we're here, stat. Okay, now you see how this says calc? There's no calc button. This means scroll over to where it says calc. So you have to use the right arrow over to calc. So stat, arrow over to calc, one variable stats. That's what that stands for, by the way, one variable stats. So hit enter. And you want to make sure that your list says L1. Does anyone in the whole class list say anything other than L1? You sure? Okay. If it says L1, we're good. Then hit enter, enter, enter. And moment of truth, did we enter our numbers improperly? Did I enter my numbers improperly? Did one other person get the same thing as me? Okay, if you got something different, don't use your calculator, just use mine. All right, so look at all the amazing things it gave us. All right, so right here, we're actually going to write down everything that we can get from one variable stats. This is the only time I'm going to do this just for this problem. I'm going to skip the next one after this. The one that says capital sigma x squared, I'm skipping that. I'm also going to skip the next one. That's the little like loopy guy. Those are things we will not be using in this class. Okay, then I want to show you that you can scroll down. And this stuff is very important. Okay, now we're going to make some notes about what these things are and what we're going to use them for. So this top one here is the mean, which you can transfer here. This one is called the checksum. It's actually not called the checksum. That's a lie. It's all the numbers that we typed in added together. We use it as a checksum. So that's the number we use to make sure that we typed our numbers in correctly. A lot of times in the CPM book, they'll give you the checksum so that you know when you do one variable stats, you didn't type a number wrong. We're not going to use it for math. We use it to check to make sure that we didn't type something wrong. It's really easy to type numbers wrong into L1. Okay, this is your standard deviation. n equals 26 is how many numbers you typed into the list. And then these guys here all have a name. It's called the 5-number summary. These 5 are called the 5-number summary. And these are what we use to make our box plot. We're going to do in a second. Okay, and I'm going to transfer the median up here. By the way, anyone that's interested in taking AP Stats, this is just a little note. Do you notice how close the mean and median are? That means that I did a good job choosing roughly symmetric. When the mean and median are far apart from each other, that means there's some kind of skew. If they're close to each other, that means that I probably chose right. It's just a piece of evidence to help with your shape. But anyway, range, IQR, and then standard deviation. Those are my 3 measures of spread. Standard deviation, I can just go right up there and write. I don't know why I did this one to 4 decimals and that one to 3 decimals. Another thing about stats is it's very loose on the decimal places, which is weird. But anyway, okay. Range is max minus min. So come over here and get your max and min. And then interquartile range, IQR is Q3 minus Q1. Oh, why are you saying that? I believe on the chapter 1 test, we ask you to make a histogram, but none of this stuff. We might ask you what the shape of it is. Can you identify shape? Okay. But also remember, on our chapter test, you get a note card. So, you know, I wouldn't devote my whole note card to this personally, but I'm going to post test topics too. Okay, anyway, this is almost the end of this problem. We have one more thing to do, which is the box plot. And the box plot goes above the histogram. Here, notice how my line went more. Okay, so that goes up here. Okay, so we start with our 5-number summary, and we're going to make vertical lines, little baby vertical lines at each of these 5 spots. So my minimum is 229, so 230. I'm going to say that's 229. And then quartile 1 is 250. That's a nice, actually on a line. That's good. And then my median is 258, which is about here. My quartile 3 is 268, which is about here. And my max is 284, which is about here. And then you connect the middle 3 to make the box. And then the outer ones are the whiskers. Now the shape of my box plot is almost perfectly symmetric, which means that I did a good job choosing the shape roughly symmetric without all of this other evidence. Yay, Mrs. Talbot, you did great. Okay, now let me set your expectations up properly for your problem number 102. A lot of time, a whole half an hour. This is what you're going to do for number 102. Are you ready? Okay, we're going to make this with group B that's on your, and you're going to describe using socks. You don't have to rewrite the calculator instructions and you don't have to rewrite all the things out of the calculator. So I want this and this, but you don't have to do this. These are just instructions. Do you need me to say that again? I want you to do this and this, but you don't have to rewrite all of this because those are instructions. Okay, and you have a whole half an hour to do it. And then at the very end of the period, I'm hoping I won't forget. I want you to try to figure out what's going on between group A and group B. So just, see if, just keep that in mind while you're working. But scale your graph the same. Make your graph the same size, scale it the same.